To talk about the Gnome rocket. The Gnome rocket is a beginner's kit, and this kit is fairly simple to put together. In about 1 hour you can have a flyable rocket. There's plenty of videos that show you how to build it, and I'm not going to duplicate those videos or teach you how to build it. What I want to do is show you how to re-engineer the Gnome rocket to make it better. Again, this whole channel is about model rocket engineering, and we're trying to find ways to solve rocket problems and to make our rockets more stable, more reliable, and to fly better. Okay, so the Gnome rocket, I bought this and I put it together. It was a very fun kit to build, very easy. I launched it, and it was a very good rocket, very good flyer. I really liked the way it flew. Had a very nice, reliable flight on it. When I went to the larger engines, which the maximum engine is an A3 or an A10 of the tiny size, a 13 millimeter, I started running into some problems. Now, the problems were kind of subtle, but it made me rethink how to rebuild this Gnome rocket. The first problem is that if we take a look at the Gnome rocket when it's done, the Gnome rocket has, by its initial build, the nose cone with an elastic cord in it. The elastic cord would hold on to the nose cone as it flies out. Now, this is called a shock absorber cord or a shock cord. It doesn't really absorb the shock. It just transfers the shock from the engine into the cord, and then the cord into the nose cone. The nose cone then snaps back, and it hits the top of the rocket, bends it, breaks it. I had one time it hit the center and made a huge dent and groove in it. So this is really a problem with almost all rockets that use the elastic cord, and that's this nose cone recoil. It has some other names, but we'll just call it a nose cone recoil. The second issue was that when this rocket was really high, I couldn't see it. So it was a great flight, but I couldn't see it. It would blend in with the clouds. It's very small. The streamer that it comes with is only about a foot long, and you can't see the streamer either. So a 1 foot rocket with a 1 foot streamer, when it's up there several hundred feet, dancing around with the pattern of the clouds behind it, you're just simply not going to see it. The third problem was when this actually came down on the ground, it was still hard to see. Sometimes I fly in an area that's got a nature preserve, and there's a central section that's nice and cut grass, but beyond this is where you've got the prairie grass, which is like 6 to 8 inches tall. It looks really beautiful. You got prairie plants, which can be 2 feet. You got reeds, which now are like 4 feet, some of them up to 6 feet. This little rocket falling into even 6 feet inch grass, you never see it. I've had a situation where I was standing right in front of it and I didn't see it. So it's easy to lose in some of these situations. The last issue, and this is actually the one that made me really think in terms of why I need to re-engineer it, was that this particular rocket has this engine clip here. And there's 2 problems with engine clips that we have to think about. One of them is during thrust, it'll thrust forward and it'll tend to tear into the material going forward. This is why rockets have this engine block or the thrust ring. The idea is to dramatically strengthen the front where this engine ring meets the engine clip, so the engine clip does not slide forward. That would be forward zippering, or maybe thrust zippering if we want to call it that. But this Gnome rocket had a different problem, is that when the ejection charge went off, the ejection charge would pull on the engine clip this direction, and it literally tore the engine clip backwards. And eventually, after 3 or 4 flights, I noticed it was coming down farther and farther, till after 1 flight, the engine just ejected and the rocket came down, nose dived and broke in half. I go, well, that's the end of that. So I took a look at that as being really a lesson in engineering, saying, can we do better? This channel, being Model Rocket Engineering, it's about how do we re-engineer this Gnome rocket to make it much better. Okay, so let's take a look at the first thing that I did. The first thing I did was to solve the problem of the ejection zippering. If you look closely, you'll see that I have the engine clip, but right underneath the engine clip I have 2 wraps of Kevlar cord. Now this is the 100-pound cord that I use on streamers and such like that. It's 100 pound. This is more than adequate. This is very thin, which is really nice. It's 0.8 of 1 millimeter. So I wrapped it around the body, and then I put the engine clip on. This will prevent the ejection zippering, so when the ejection charge goes off and tries to pull the engine clip backwards, it's going to hit this ring. This acts like a thrust ring for the ejection process. To keep this in place, I put some glue around this. The glue that I used, and I rely on this glue called E6000. It's a hobby cement. You can buy it almost any hobby store, hardware store. It's got many different sources. It's a very good glue for gluing to almost anything because it glues and sticks to almost any material. Now here's the interesting thing about it. This particular glue, and I comment about this a lot because people will use it but maybe not for the right application. This glue is very similar to an epoxy. It has a resin, but instead of a hardener, it has a solvent. So the solvent needs to evaporate so that the hardening process takes place very slowly. So it'll dry in about maybe like 20 minutes. It'll still be rubbery for about an hour. And this glue specifically says it may take 1 to 2 days to reach full strength. So if you do use this glue, be prepared to let your model set for at least 2 days for this glue to maximize its strength. And once it does get its maximum strength, it's going to have the strength of an epoxy resin. This glue is very, very nice. The other thing about this glue is it's got a rubbery base, a silicone polymer, I assume. And the silicone polymer has a little bit of give to it, so if you yank on it, it's not going to chip or crack, but rather it's going to stretch just a little bit. And that's really good in model rocketry because things are always being pushed and bent and stretched. So the first thing to fix the problem that I have is to put a double wrap of this 100-pound Kevlar cord just underneath this engine clip here. Now, what I also did is this also has a 4-foot extension which goes inside of the rocket right at this point. So that goes inside. So inside of this, I now have a 4-foot length of this 100-pound cord. Well, that solves a couple of problems. It solves the problem now of this zippering backwards, and it solves the problem of getting rid of the shock cord, the elastic shock cord that we don't want to use. So now let's take a look at what I stuffed inside of this. Matter of fact, I showed this to one of the model rocket clubs. They're immensely surprised. It's like, wow, you actually put a long streamer inside of a Gnome rocket. Keep in mind this is only a 1/2 inch wide and it's about 10 inches long, so we don't have a lot of space to work with. But I'll show you what I did. If we take a look at the inside, we have the nose cone, and the first thing we see is I have a Kevlar felt ejection blanket. This ejection blanket holds a 1-inch streamer module, and the 1-inch streamer module, this is not connected with a toothpick. I didn't have enough space in there. It's just simply taped onto the end. This streamer is 8 feet long. So if I unwind this, we can see that not only is it 8 feet long, but I also do the winding on this such that I do the center wind, where now I have the two ends together. The center of the streamer is the center of this actual streamer module. So this again is that so-called center winding that I've been demonstrating. Again, I don't see this talked about anywhere else, so I think this is fairly new or clever, whatever you want to say, but it works great. And I recommend that if you want to fly long streamers that you do this, because the stress on the center of the streamer will pull open, will be relieved when this pulls open, so that curliness that you get in the streamers goes away. It just counterbalances itself. It's really, really nice. So again, this is the center winding, where the center of the streamer is actually the center of the winding, and this winds forward like this and creates our streamer module. So this is all wrapped into an ejection blanket. And again, I don't have a toothpick on here or anything rigid. I just have 2 layers of tape holding in. That's sufficient. It's only an 8-foot, 1-inch streamer. Likewise, to save some space, this particular ejection blanket is fairly small, and we can measure that very quickly. This blanket is about 3.5 inches long and about 3/4 of an inch across. It's big enough to just simply wrap this streamer module, and that's about it. Once this is wrapped, that's all we can fit into this. Now, this particular rocket was rebuilt at a point where I was experimenting with streamer blanket mounting and all the knots and everything. So this one I opted to, again, keep it simple. All I do is just say, okay, I've got my Kevlar line. There is a knot here with the loop, which I usually do. But instead, I just simply glued this directly onto the Kevlar line. So the blanket is hooked on here directly. I do not have the eyelet, which I do use later on. But again, for a fairly small streamer, this is not going to make much difference. So again, this is the other engineered change that I have is the streamer module, 8 feet long by 1 inch wide, the Kevlar blanket, and it's glued directly onto the Kevlar line. And as promised, we do have a nice long 4-foot cord in here. So you can see, and this one does not have a swivel as well. And this is why I show in a particular video how to do connection of nose cone and blanket when you do not have a swivel in this end. So this is put in there permanently, and you can see that this goes down and it wraps around the body right here. So this one solution solves all these problems. It solves the backward zippering, and again, a little bit of E6000 glue on this just to stick everything down. It's a very, very good glue for doing that. The cord goes inside and comes out here. No swivel, but it is 4 feet long. This is our new, this replaces the shock cord. And if you think about it, by not having the elastic cord with the anchor inside, this whole entire tube is now smooth, so everything just slides out real easily. Again, I like my rockets to be reliable with the smooth inside, not having that anchor. The Kevlar felt slides out real easily. It unwraps the streamer very easily. And now when this goes up, I've had this fly up, and our launch control officer said, "Where did it go?" I look up, I said, "Just watch for the sparkle." And eventually this 8-foot streamer popped open. We saw the sparkle, and we just followed the sparkle, and eventually it landed. This actually had landed about 300 feet downrange. That's quite a distance. And it turned out the upper winds were fairly strong. But we could see it. We could see exactly where it went. And when it went down, I could easily go find it. Another launch, this did land in the nature preserve area, and it landed in the weeds, not the weeds, the prairie grass. And I was standing right next to the rocket. I can see the streamer. The streamer laid on top of the prairie grass. The rocket had fallen underneath. I was standing right next to it, right in front of it. I never saw it. And I go, well, I'm glad I've got the streamer, because the streamer allowed me to spot it when it was on the ground. So the crackling streamer in the air, the nice sparkles allows me to see it. This long Kevlar cord prevents the nose cone from snapping back. And the Kevlar wrapped around the base here on the engine mount prevents the backward zippering. So all problems were solved by using just this one solution, which is this Kevlar ejection system and recovery system. So I do highly recommend buying 2 Gnome rockets. Build the first one exactly as specified so you get familiar with how it works. And then the second one, do some advanced stuff, which is, again, what this channel is about. Show you how to do some more advanced capabilities with your rockets. This Gnome rocket now has flown dozens and dozens of flights. Whenever I go to fly, this is the very first rocket I put up. Even if I'm at the high power range, you stick an A3 in this thing, an A3 4T, and it flies so high, people think it's a high power rocket. No kidding. And then you see that sparkling little streamer. It just is a very nice flight. This is the first rocket that I send up every time I go somewhere to check the upper winds and to see what the drift is going to be. And for an $8 rocket and a little bit of Kevlar, you're going to have some spectacular flights on this rocket. I highly encourage building one rocket as is, build the second rocket with this Kevlar recovery system and a streamer, and you're going to be in business for some very, very reliable flights. Again, I've not had any damage on this since I've put the Kevlar. There's been no damage to the nose. I've not had any problems with this zippering. Wonderful rocket, just needs a little bit of engineering work. Okay, thank you.